Hi guys, so today I'm going to talk about mole theory and what a mole is in chemistry. So moles are actually the unit that chemists use in order to measure matter. So atoms and molecules are so small that we need a huge number of them before we even get to a point where we would be able to see them with the naked eye. So that's why we use moles, because moles is a specified number of particles, and that specified number of particles is huge. So 1 mole is defined as 6.02 times 10 to the 23rd power particles. Now a particle is either an atom or a molecule or a formula unit. It depends on what you're talking about, which of those terms you would use. But all three of these terms are particles. So this is the definition of what a mole is. This is how many particles make up a mole. And it is true for any substance that you can think of. 1 mole of that substance is always going to be 6.02 times 10 to the 23rd power particles of that substance. So to convert between particles and moles, this is my conversion factor that I would use. So to look at a problem, I have 5.79 times 10 to the 26th atoms of carbon, and I want to know how many moles of carbon do I have. So to set up this problem, I take my given, which is what I know that I have, my 5.79 times 10 to the 26th atoms of carbon, and that is where I start. Now it's very, very important that you always have your unit with your numbers when we do these kind of problems. And the unit includes not only atoms, but also carbon. So the complete unit is atoms carbon. I need both pieces in order to be correct. So I can take this given and I can make it look like a fraction. Now that will help me visualize what I need to do mathematically to solve it in a second. So my given, I'm going to take it and I'm going to multiply it by my conversion factor. And I want to set up my conversion factor so that I'm factoring out or getting rid of atoms of carbon. So to do that, I'm going to take atoms of carbon and I'm going to put it on the bottom of my conversion factor. Because that way they will factor out or they will cancel each other out when I do this mathematical process. Now, the unit that I want, moles of carbon, is going to go at the top. Now to finish out my conversion factor, I just need to put my numbers in. So when you have a conversion factor, you need to think of the number and the unit being super glued together, meaning wherever the unit goes, the number has to follow. So in this example, moles went on the top. So I'm going to take 1 and put it up on the top with mole so that the number stays with its unit. So the two follow each other no matter what. And atoms is on the bottom, and an atom is a particle. So I'm going to take 6.02 times 10 to the 23rd power, and I'm going to put it on the bottom with its unit. And when I do that, now I'm ready to calculate. So atoms of carbon is going to go away, and I'm going to be left with moles of carbon, which is what I was asked for, so I know I've done it correctly. And then to calculate, I'm going to take my top row of numbers and multiply them together. And I still have my unit at the top, moles carbon. I'm going to take my bottom row of numbers and multiply them together. And I don't have a unit left anymore on the bottom because it canceled out. So now what I'm going to do is I'm going to divide. And when I divide, I want to be sure that I enter this into my calculator correctly. And because this is scientific notation, sometimes it gets a little tricky to enter it correctly, and have my calculator do what I think it's supposed to be doing. So one of the ways that I make sure that I always enter numbers in scientific notation correctly is I use the EE button. So on this calculator, the EE button is the second function of this x to the negative 1. It's directly above the 7 button. Okay. So I would enter 5.79, okay, and then I would hit second, and then this button right here gives me an E. Now this E represents the times 10 portion of this value. So the only thing I have to do now is enter my exponent, 26. And then I'm ready to divide by 6.02, second, E, and then my exponent, 23. And I can hit enter. And so this is my mathematical value of that division. So 961.794, on and on, with my unit moles of carbon. So the last step of this is to get my sig figs correct. And for sig figs, the only place I look is at my given value. And since it's in scientific notation, I actually ignore the times 10 part. And the only place I look for sig figs is right here, 5.79. So that is 3 sig figs, which means my answer should be rounded to 3 sig figs so that they match each other. So if I round this to 3 sig figs, okay, the 7 next to the 1 tells me that I need to round up. So this is going to round to 962 moles of carbon, because I need to be very sure that I keep my unit on that number. So then my final answer here is 962 moles of carbon. This also works if I'm going in the other direction. So instead of particles to moles, I can use this same conversion factor to go from moles to particles. So I'm going to do the same thing. I have 3.2 moles of H2O, and I want to know how many molecules of H2O I have. So I'm going to take my given, what I know, 3.2 moles of H2O. I can put that over 1. And now I want to set up my conversion factor so that I factor out or cancel out moles of H2O. So moles of H2O, that unit is going to go on the bottom. And then the one that I want, molecules, is going to go at the top. And then just like before, the number and the unit are super glued together. So this time, moles is on the bottom. So I take the 1 and I make it follow its unit, moles, to the bottom. And molecules are going to be at the top, so I'm going to take 6.02 times 10 to the 23rd and make it follow its unit up to the top. So this time, it's going to be 3.2 times 6.02 times 10 to the 23rd along the top as a multiplication. So I have 3.2 times 6.02 E23, which gives me 1.9264 times 10 to the 24th. And that still has molecules as the unit. And then along the bottom is 1. And moles of H2O has canceled out. So dividing by 1 is just itself. So this is 1.9264 times 10 to the 24th molecules H2O. And that's my mathematical answer. So I look back at my given, 3.2, and I see that 3.2 is 2 sig figs, so I want to round my mathematical answer to 2 sig figs. So this 2 tells me that my 9 should stay the same, so my final answer should be 1.9 times 10 to the 24th molecules of H2O. And that would be my final answer. Now I don't just use moles to go from particles to moles or moles to particles. More commonly, I use moles to get to mass, and we call that the molar mass. So on your periodic table, there is a mass listed, and that's called the atomic mass. But more commonly, we think of it as the molar mass, meaning that 1 mole of any element is equal to the mass that is listed. So in this example, you can see that I have lithium is equal to 6.941 grams per mole. And grams per mole is the unit of molar mass. Because what that means is that 1 mole of lithium has a mass of 6.941 grams of lithium. And this number came directly off the periodic table. So if I look at lithium on the periodic table, I can see that its mass is listed as 6.941. So its molar mass is 6.941 grams per mole. So these, for any element, the mass listed, its molar mass is this number, and that means that 1 mole of that element is equal to that many grams of that element. I can also use this to find molar mass of compounds. So for example, if I wanted to find the molar mass of calcium fluoride, the formula for calcium fluoride is CaF2. So I'm going to take my molar mass of calcium and I'm going to add it to 2 times the molar mass of fluorine, because I have 2 fluorine atoms in 1 formula unit of calcium fluoride. So on my periodic table, I found that calcium had a molar mass of 40.08 grams per mole, and fluorine had a molar mass of 19.00 grams per mole. Now I'm going to multiply that by 2 to represent the 2 atoms of fluorine from my formula. So when I add these together, I get 78.08 grams per mole, which means that 1 mole of calcium fluoride is equal to 78.08 grams of calcium fluoride. And I can use this relationship to help me convert between mass and moles, or in other words, grams and moles. Okay. So to do that, if I wanted to know how many moles of lithium I had, if I had 14.8 grams of lithium, I would use this relationship right here. 1 mole of lithium is equal to 6.941 grams of lithium. And remember, I found this right on my periodic table. So this setup is the same that we have been doing. I take my given 14.8 grams of lithium, and I can put that over 1 if I want. Now I'm going to set up my conversion factor to get rid of grams of lithium. So grams of lithium goes to the bottom. And I want moles of lithium. So moles lithium goes to the top. And just like before, the number and the unit are super glued together. So moles was at the top, so the 1 is going to follow the moles to the top. And grams was at the bottom, so 6.941 is going to follow grams to the bottom. Okay. So when I multiply across the top, after canceling my units, I have 14.8 moles of lithium, and then 6.941 is on the bottom. So now I can divide. Okay. So 14.8 divided by 6.941 gives me that as my mathematical answer, so 2.1322576, and it's still the unit moles of lithium. So now I need to get my sig figs correct. So 14.8 was my given. It has 3 sig figs, so I need to round my answer to 3 sig figs, which means this is going to round to 2.13 moles of lithium. And that would be my final answer. I can also do this the other way, so from moles to grams. So here I want to know how many grams of calcium fluoride are there in 2.4 moles of calcium fluoride. So this time I'm going to be using this conversion factor to help me do that. So I take my given, 2.4 moles, calcium fluoride, and I'm going to set up my conversion factor to factor out moles. So moles of calcium fluoride goes on the bottom, and grams, the thing that I want, goes at the top. So moles cancels. Now, grams was at the top, so 78.08 is going to follow grams to the top. And moles was at the bottom, so moles is going to be where the 1 is following to the bottom. So 2.4 times 78.08 gives me 187.392, and I still have my unit grams of calcium fluoride, and 1 times 1 gives me 1, and anything divided by 1 is itself. So I'm just going to skip writing that part and go straight to how many sig figs do I need. So 2.4 was 2 sig figs, so I need 2 sig figs here, which means I'm going to round this to 190 grams of calcium fluoride. And remember, as long as I don't put a decimal point at the end of that number, that 0 will not be significant, so that would be 2 sig figs in my final answer here. 190 grams of calcium fluoride. So moles are very, very helpful. They act like a superhighway, and I can really do a lot of conversions. I can even convert volume to moles. Now this only applies to gases, and specifically gases at standard temperature and pressure, or what we call STP. So STP is 0 degrees Celsius and 101.3 kPa. And kPa stands for kilopascals, which is a unit of pressure. Okay. And the relationship is, for 1 mole of gas at STP, it fills a volume of 22.4 liters of that gas. Now this is a relationship specifically that we're going to talk about next unit when we do gas laws, but there is a molar relationship for gases at STP between moles and liters. And to look at all the relationships, we have something called the mole triangle. For most of our conversions that we're going to be doing, we're going to have to get to moles first, and this is the reason why. Moles is like my superhighway, which allows me to go anywhere that I might want to go. But I cannot go directly from mass into particles. It doesn't work that way. I have to go to moles first, and then I can go from moles to particles. Or if I want to go from particles up to liters of a gas, then I'd have to, again, go from particles to moles, and then moles up to liters of gas. So I always have to go through moles first, and this is just kind of showing the relationships between these various units with moles at the center. So moles are incredibly helpful, and they're going to be something that we will be using for the rest of the year together.